This is one of the additional videos to our circular motion, and I got an email from a student that is asking me to record this video, so I'm gonna do this specific question for this video. So the question that I was asked to record is an amusement park ride consists of a large vertical cylinder that spins about its axis fast enough that any person inside is held up against the wall when the floor drops away, so the person is not going to slide down. The coefficient of static friction between the person and the wall is given mu 0.5, and the radius of the cylinder is 10 meters. And then how fast should the cylinder be moving for the person not to fall down when the floor is gone? So I'm going to draw the forces acting on the person when the person is stuck to the wall. So if this is the wall, and if this is the person stuck to the wall with the feet, eyes, nose, the forces acting on the person are friction to hold the person from sliding down, so this is friction, the force of gravity, which is mg, and the normal force. And your normal force is your centripetal force. Without that force toward the center, or the normal force, the person would not be able to move in a circular motion. So the normal force in this case is your centripetal force. So that is AC. And the friction force is equal to the friction force minus mg is equal to 0. So the friction minus mg is equal to 0. I'm using the F net is equal to ma. So vertically, the person is not accelerating. Horizontally, the person does accelerate because the person is moving in circular motion, so that's mv squared over r. But vertically, there is no acceleration, so the net force is equal to 0. And then I can solve for friction is equal to mg, so I'm going to rewrite this as normal again is equal to mv squared over r, the centripetal force formula, and the friction is equal to mg. I moved mg to the other side. But the friction force also has a formula which is mu times n, and we know what n is equal to from the equation above. So that gives me mg is equal to mu, and instead of n I have mv squared over r. So m and m can be cancelled, and they ask me how fast should the cylinder be moving. So they ask me for velocity, and if I want to solve velocity, I'm gonna times by r both sides and divide by mu. So v squared is equal to rg divided by mu, and then I take the square root of both sides. So the velocity is equal to rg and mu in the denominator. The square root of r is given 10 meters, g is 10, and mu is 0.5. So v is equal to the square root of 200 and equals to 14.14 meters per second. In AP physics we do this, but in regular physics we skip this concept, angular velocity. So there is a relationship, so this is for AP students. There is a relationship between the angular and tangential velocity. So your angular velocity is equal to r times an angular velocity, or your linear velocity is equal to r times angular velocity. So if you want to solve for the angular velocity, in this case, you have linear velocity divided by the radius, which is 10, and that gives you 1.1414 radians per second. So that would be the angular velocity of the motion presented in the problem. And again, this is for AP physics students, not for physics students. In this question, they ask you to find, so it's the same setting, the person is stuck to the wall, the whole amusement is moving at certain velocity, and they actually tell you that the person is spinning with the frequency of 15 revolutions per minute. So the person makes 15 circumferences, which is 2 pi r in 1 minute, so that is 60 seconds. So that will give you velocity of the person. So it's 15, 2 pi r is the distance traveled, and time is 60 minutes or 60 seconds. So your velocity is equal to the distance over the time, and the distance around the circular motion is the circumference, which is 2 pi r. Over the time, they give you 60 seconds or 1 minute. But the person makes 15 of them in 60 minutes, in 1 minute. So that means I can actually divide by 15 and 15, the top and the bottom, or numerator denominator. So I'll have 2 pi r and 4. I can also divide by 2 by 2, so I have pi r divided by 2. And the radius is given 10, so I have pi times 10 divided by 2, which gives me 5 pi meters per second. So I can cancel, divide 10 by 2, I get 5 pi meters per second. I can convert pi into 314 and multiply it by 5, which will give me 15.6, but I can also just leave it 5 pi. So that is the velocity. So that would be 15.7 meters per second, or 5 pi. And then they ask you, what is the normal force acting on by the wall on the 50 kilogram rider? So now they give you the mass. And your normal force, again, it is in this direction. So right here, I'm using the green marker. So it is toward the center, so that's centripetal force, or the normal force. So your normal force in this case is your centripetal force again, and it equals to mv squared over r, the formula for centripetal force. It's mac, and ac is equal to v squared over r. So the mass is given, which is 50 kilogram. V squared, so I have to square each one of the velocity terms, so that's 25 pi squared over the radius, and the radius is given 10. So I can cancel 10 and 10 from the top and the bottom, and I get 125 pi squared, and its force, so it's measured in newtons. So the normal force is equal to the force of centripetal force, and equals to 125 pi squared. And then the last question, they ask you to find the minimum coefficient of friction. So if, again, here is the wall, and if the person is stuck to the wall, then the forces acting on the person is friction, the normal force, friction, and the force of gravity. And then from here, I can say again that the normal force is your centripetal force, which is calculated as 125 pi squared newtons. And the friction force must be equal to mg in order for the person not to move up and down, or you can say the friction minus mg is equal to 0. The net force is equal to 0. So from here, I can say that the friction is equal to mg. But the friction is equal to the mu times n. So instead of the friction, I can write mu, so that's the friction force times n, equals to mg. And they ask me to find the coefficient of friction, so that's mu is the coefficient of friction. So mu would be equal to mg over the normal force, which is the force of friction. So m is 50, g is 10. Normal force, I just calculated what the normal force is equal to right here. So the normal force was the force of friction, and equals 125 pi squared. And that will give me that the coefficient of friction is equal to 0.4. And that is it for this video. The video related to the questions that the students were asking. Thank you for watching, and see you in the next one.